Inverse trigonometric expressions. This is a Leaving Cert higher level example. Express the cosine of the angle sine inverse of x in terms of x. Let's call this angle theta. It's just easier to look at. So if sine inverse of x is theta, then sine of theta is equal to x, or as a fraction x over 1. So if we imagine a triangle where the opposite is x and the hypotenuse is 1, we could use Pythagoras' theorem to work out the adjacent side here. So we could see that the square on the adjacent is 1 minus x squared. Therefore, the adjacent side is the square root of 1 minus x squared. So now we have enough information to find the cosine of this angle. So the cosine of theta, or sine inverse of x, is equal to the adjacent over hypotenuse, which is the square root of 1 minus x squared, over 1, which is the same thing as the square root of 1 minus x squared. So that's the solution. The second question, to evaluate sine of 2 times the angle tan inverse 4 over 3. Again, I'm going to call tan inverse 4 over 3 the angle of theta. I'm going to imagine a triangle. So tan theta must be 4 over 3. So that's the opposite over the adjacent. Compared to this angle theta is 4 over 3. We might recognize this triangle that the hypotenuse here is 5, but we could work it out using Pythagoras' theorem if not. So we want to get sine 2 times theta, or 2 times tan inverse 4 over 3. To do this, we'll use this formula here, that sine 2a is equal to 2 sine a cos a. So now all we have to work out is sine of theta, which is 4 over 5 from the triangle, and cos of theta, which is adjacent over hypotenuse 3 over 5. So we can sub these fractions in to our expression. And now just multiply it out. So we see our numerator is 24 and denominator is 25. And that's the answer.